Last of all, in this high-speed trains practice situational problem, we have question 7. Question 7, for the new train station Trois-Rivières, the government wants to install a security camera on top of a pole. However, the camera needs to be able to see the bottom of the train when it is on the track. There is a ticketing office building in the way that will block the camera if the camera is not high enough off the ground. Ticketing offices are 12 meters long. You see that here, it's showing in the diagram. And 3 meters high. That's how tall the ticketing offices are. The train track begins 4 meters away from the ticketing offices. You just see that there. What is the minimum height off the ground? Notice that's in all caps. That's kind of a hint that, all right, it's easy for me to forget this here, right? Like if you found how tall this is from the top of the ticketing offices, that wouldn't answer the question how far it is off the ground. Very important in a situational problem that you're actually answering the question that's being asked. In this case here, if I make it high enough for it to be able to see, it's not asking me what's the maximum height it could be. It could be way up here, up in the text, and be able to see the bottom of the train fine. I'm saying what's the minimum height so that it gets past this corner and allows me to see here. So in this problem, the biggest difficulty is probably realizing what kind of math is going to help you here. This, in case you didn't figure it out, and if you didn't figure it out, that's probably why you're watching this video, is a similar figures problem. Similar figures, that just means where I'm dealing with two shapes that are the same shape but different sizes. Typically, I mean, they can be the same size, but usually they're different sizes. And here, let's see, what's the best tool for me to use this? Annotate with a line. I want to show you guys here, and I'm going to make it a line that's actually visible, just for fun. I'm going to make it nice and thick too. So this thing here is a line that goes from the camera to the spot. You see in the question it says that the camera must be able to see the bottom of the train. The arrow is saying this is your bottom of the train right here. So when this line is in place, it's a little bit easier to see, oh, maybe this is clicking with me here. I'm dealing with two similar triangles. When you have a diagram, it's a tool for you to use. You can manipulate it. You can do stuff with it and make sure to make use of that tool. If there's no diagram at all, it's often a good idea to build a diagram. Here, even when you're given a diagram, you can mess with it, chew on it, make your hands do the thinking for you. So when you draw this line here, that might help you click, okay, I see I've got a triangle here. This angle here is going to be congruent to this angle here. The angle down here is congruent to this angle here. And that means, most importantly, that the ratio of the sides of this triangle is going to be the same as the ratio of the sides in the similar triangle here. That means that I can set up a proportion to solve my problem. So let me get out the little tableau here so I can write some stuff for you. That means I can set up a proportion. I can say this leg of this right triangle, this is like the upright leg of the right triangle over the base of the right triangle, is going to be the left side of my proportion here. And I'm going to put units on this just to keep myself honest. I have 3 meters is the upright leg and 4 meters is the base. Let me put a little line here to make clear that we're dealing with a fraction. And then in order to make this proportion work for me, setting up the proportion properly, that's really the whole problem right there. I have to make sure that if, okay, this is the little triangle, the left side is little triangle. I'm reminding myself that. That means everything over here is going to be big triangle. And the numbers that I put up here and here have to match the corresponding sides of this triangle. So in the way that these triangles are set up, the 4 corresponds to the 12, and the 3 corresponds to this side here, which I don't know. So since the 12 lines up with the 4, that means that since the 4 is on the bottom over here on my small triangle side of the proportion, I'm going to put 12 meters as my denominator on the big triangle side of the proportion. And I'm going to put a little line here. This shows me now where my empty space is, and if I'm handy with finding missing terms and proportions like so many of you guys are, this now suddenly becomes a very easy problem. I can just do 4 times x to get 4x is equal to 36, and then solve for x to get x is 9. Or, like a lot of you guys prefer, you do a little mental shortcut. 12 times 3 is 36, divided by 4 gives you 9, and x equals 9 meters. Now, Since you're smart and you're keeping in mind that in a situational problem, I always have to answer the question that's being asked and not just stop when I come up with some kind of answer that feels good. Say to yourself, what is the minimum height off the ground? Yay, congratulations to me. I figured out that, well, that's a very small thing. Let me make it something you can see a little bit better. A color like big red. Make it nice and huge. Now there's a good 9 meters. That's a much better thing. Okay, so I figured out that that's 9 meters there. And since this is 3 meters here, then to find the total height off the ground, the minimum total height off the ground the camera has to be, I just do 3 plus 9 to give me 12. And that's the answer to this question here.